All right, let's go through it. So the sum of all the a sub n's will diverge if the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n is greater than 1. But if that exact same limit value is equal to 1, then the ratio test would be inconclusive, as in we wouldn't be able to say whether the sum converges or diverges. Because the point is that when it flatlines, had it already gone to 0 fast enough or not? And you wouldn't especially know that using this type of a test. So there you go. You should memorize that, and you should memorize that now, and make sure you don't forget it until your AP exam is over. You'll see ratio tests coming back here and there as we go through the last half of chapter 8 and when you get to the AP exam. Okay, for example 1, the directions say use the ratio test to determine the convergence or divergence of each series. And I hope as you look at these series for parts A and B, I do hope that it makes sense that we wouldn't have had another way to figure these out if it wasn't for ratio test. So I'm going to go ahead and do A with you, and then I'll butt out and, let you do part B. If you already think you know what you're doing, then go ahead and pause the video, do your own thing, and then watch what I have to say. But I'll model it for you here. So notice that with the ratio test that you always need to find out what this expression is doing, okay? And it's just a matter of on what side of 1 is it? So for ratio test, you're going to need to figure out what's the limit as n goes to infinity of a sub n plus 1 over a sub n. You're going to need to figure that out. And so this is a sub n. This is how we're defining the nth term. So now let's go ahead and show what this would equal for this particular problem. So a sub n plus 1 would be 3 to the n plus 1. I'm just replacing all the n's with n plus 1 over n plus 1 factorial. And then we're dividing it by a sub n, which would simply be 3 to the n over n factorial. And then from here, let's clear that compound fraction by flipping and multiplying. So we'd have the limit as n approaches infinity of the absolute value of 3 to the n plus 1 over n plus 1 factorial times n factorial over 3 to the n. So just a little flip and multiply there. And then from here, the point is to simplify the heck out of this expression. So we're going to actually factor some of the pieces in a way that would help us with canceling stuff out. So let's start with 3 to the n plus 1. I hope it makes sense. That equals 3 times 3 to the n. And then n plus 1 factorial, that equals n plus 1 times n factorial. And then I'm just going to bring the rest down. And then I hope you have good sound effects, because in my opinion, that's what's going to make chapter 8 fun. So, I don't know, whatever you got there. And so simplify this. We'd have the limit as n goes to infinity of the absolute value of 3 over n plus 1. I think that's all that's left after all of that destruction. And what do we get when n goes to infinity on this expression? I hope it makes sense that this would fairly clearly equal 0. And so now that we're here, you just need to figure out, well, on which side of 1 is that 0? And it's less than 1. And so at the tail end, this thing starts thinking it's a geometric with a common ratio of 0. Anyway, so we would say the sum as n goes from 1 to infinity of 3 to the n over n factorial converges. And not only does it converge, but it converges absolutely by the ratio test. All right, my friends, see if you can, how you'll do with part B there, and check in with me in the next video. Good luck.